Yes, good morning students. This is Ellen brand of chemistry. We are going to discuss solution chapter, right? So solution, first of all, what is the solution? So what is the solution? So generally when we are discussing any statements, so salt solution, sugar solution, like that we are using, right? The solution word we are using, right? So solution, nothing but, sir, for example, in case sugar solution, if you take sugar solution, in the sugar solution, sugar is present, then water is present. Sir, in that sugar particles are entire solution will be present. Entire solution will be present. Sir, in case if you see that solution, sir, we cannot identify sugar particles is there or not. But entire the sugar particles, so uniformly distributed throughout the solution. But it is not visible to see. It is not visible to see, which are sugar particles. So that is called homogeneous mixture. What we call homogeneous mixture. Homogeneous mixture means, sir, all the particles of solute, entire solvent uniformly distributed. That is called solution. So solution, nothing but a homogeneous mixture of two or more components in solution. Two or more components. Generally in this chapter, binary solutions we are using. Binary solutions, nothing but in a solution two components only are present. How many components? Two components only present. So in the two components, one is solute, one more solvent. Sir, in this particular chapter we are using about the binary solutions only. So trinary solution, in case trinary solution, nothing but three components are present in it. Three components are present. So such type of solutions we are calling trinary. So in case tetranary solution, four components are present. Tetranary solution, then how many components are there? Four components are present. So this is binary solution. So entire chapter we are discussing about the binary solutions only. Sir, binary solution, nothing but one solvent, one solute is present. Sir, in this what is the solute, what is the solvent we have to discuss. Sir, first, in case if you take solute, so less quantity of the component, less quantity of the component in solution, less quantity of the component in solution is called solute. Sir, what is the solvent? Sir, solvent, nothing but large quantity of the component, large quantity of the component is called solvent. For example, in case 10 grams of NaOH present in 50 grams of water, like this will be there a statement. 10 grams of NaOH is present in 50 grams of water. So if you see the amount, which is the large quantity, which is the less quantity, it will be understand to you. So which is the less quantity will be there, that is we are calling solute. Which is more quantity will be there, that is we are calling solvent. Solvent. Sir, in case, so some cases they are giving like this, 50 grams of NaOH present in 50 grams of water. Then how we can identify which is the less quantity, which is the more quantity? Sir, even in this case also, one is solvent, one is solute, right? Because it is a solution. How can I identify? Sir, how can I identify? So you have to convert it into the moles first. Sir, moles nothing but number of moles. Moles nothing but given weight divided by gram molecular weight of the particular component. Sir, weight how much is given? 50. Then molecular weight how much is there? 40 for NaOH. Na 23. Then oxygen 16. Hydrogen 117. Right. So this is next for this, in case if you want to find out number of moles of H2O, in case if you want to find out weight how much is given, weight to molecular weight how much is given? 50, then divided by molecular weight 18. Sir, you can say which is less quantity, which is more quantity. Sir, definitely this is the less quantity, right? Then this is more quantity because denominator is less. Yes, more quantity. So this is more quantity, nothing but water is the more quantity, it is solvent. Solvent. Then less quantity will be there, that is solute. Clear all of you? So in case in the statement both weights are same will be there at that time. So you have to convert into the number of moles. Then which is the less number of moles are there, then we call it is solute. Which is more number of moles are there, that we call solvent. Clear all of you? So here to convert the number of moles, number of moles. So moles generally we have to represent with small n. So number of moles equals to given weight divided by gram molecular weight, that is number of moles. So in case weight not there but the number of molecules are there, at that time, so number of moles it is equals to given number of molecules divided by 6.023 into 10 to the power of 23. What is this? Avogadro number. So Avogadro number have to use. Sir, some other cases number of moles it is for mainly gases. Gases when it is present in the STP conditions, we have to use this formula. Sir, what is the formula? Sir, given volume at STP conditions divided by 22.4 liters. This is. So these three are calculate the number of moles in case if they will give weight, or in case if they will give number of atoms or number of molecules, or in case if they will give then volume at STP conditions. So this is the formula we have to use for the number of moles. Sir, from the number of moles, sir, in case if you want to find out the weight, given weight, sir, weight in case find out, sir, weight it is equals to weight of component or compound. Weight of compound is equals to number of moles into gram molecular weight you have to take. Number of moles into gram molecular weight if you take, then you can get the weight, exact weight, how much will be there. So in case in the statement, so number of moles of component is there, if they will ask weight, then at that time you have to take it as this formula to calculate the weight of the particular component, then it is equals to number of moles into gram molecular weight. For example, 2 moles of NaOH is present. NaOH is present. Sir, what is the weight of 2 NaOH. Sir, NaOH weight you have to find out. So weight of the compound, it is equals to number of moles into gram molecular weight. Weight of the component, if you want to find out, the number of moles first. Number of moles, how many are there? 2 moles. Then gram molecular weight of NaOH, so that is 40. Then weight of that particular component now 80 grams. So like this. So number of moles if they will give, you can convert it into the weight. Then weight if they will give, you have to convert it into the number of moles. So these formulas we have to use. Next, so look at now concentration terms we have to use. Concentration terms. So what are the concentration terms? So these can relate in between the solute and solvent. So it can relate solute and solvent, nothing but how much quantity of solute is present in the particular solvent. So this can be relates, which are concentration terms. Sir, what are the concentration terms are there? Sir, first one we have to discuss weight by weight percentage. Weight by weight percentage. Sir, or otherwise we call it is by weight. By weight. Sir, by weight. So this is also represent like this, W by W percentage. So weight by weight percentage or by weight or W by W percentage. Sir, how to find out in case such type of components they will given? Sir, here percentage, weight by weight percentage of solute, in case if they will ask. Solute. Sir, how to find out? Sir, weight of solute divided by weight of solution into 100. By using this formula you have to find out weight by weight percentage of solute or solvent. So now in case in the statement if they will give 10 weight by weight percentage of NaOH solution, like this will be there. So what does it mean? What is the meaning of 10 weight by weight percentage of NaOH solution? So here 10 grams of NaOH present in 100 grams of solution. 100 grams of solution, or otherwise 10 grams of NaOH present in 90 grams of solution. Sorry, 90 grams of solvent. 90 grams of solvent. In case if you take only solvent, that means solution weight, it is equals to solute plus solvent. So solute weight, this is the solute, that is 10 grams, plus solvent weight, this is so 90, then total should be 100 grams. Understand all of you? Sir, wherever in the statement, so like this if they will give, so 20% of weight by weight or 20% of by weight of NaOH, if they will mention like this, by weight or weight by weight. Sir, both cases you have to take, that is 20 grams of NaOH present in how much? 80 grams of solvent or 100 grams of solution. In case if you take solution, that should be 100 grams, like this. So this is what I told, weight by weight percentage. Then volume by volume percentage. Sir, second one, second concentration, volume by volume percentage. Volume percentage. Volume by volume percentage. Or we call it as by volume. By volume. By volume or volume by volume percentage, like this also we can note it, we can identify like this. So now, sir, what is the volume percentage of volume by volume percentage of solute, if they will ask solute? Then now volume of solute divided by volume of solution into 100. You have to take volume of solute divided by volume of solution into 100. Sir, same thing, sir, volume by volume percentage of solvent, if they will ask solvent, it is equals to what you have to take? Volume of solvent have to take, then divided by, sir, volume of solution have to take into 100. So like this you have to. Even in this case also, in case if they will mention 10 ml of sir NaOH, if they will mention 10 ml of NaOH. So now, so 10 ml of HCl will be there in case. HCl will be there. Sorry. 10 volume by volume percentage of HCl will be there. At that time, we call it is 10 ml of HCl present in 100 ml of solution. 100 ml of solution or 10 ml of HCl present in 90 ml of solution. This is, sorry, solvent. Clear? Right. So this is volume by volume percentage. Then third one is there, that is weight by volume percentage. Weight by volume percentage. Weight by volume percentage. So now, sir, weight by volume percentage of solute, if they will ask. Solute. Weight of solute divided by volume of solution into 100. Sir, for example 10% of weight by volume percentage of NaOH means 10 grams of NaOH present in 100 ml of solution. 100 ml of solution. Now we cannot separate the solvent here. So at this case, which is weight by volume case. Understand all of you? So these three are percentages. One is weight by weight percentage, one more volume by volume percentage, another one weight by volume percentage. So now we have to discuss some of the problems based on it. Sir, how to solve such type of problems, that we have to discuss now. Look at, So look at in the previous what we had discussed, that weight percentage, volume percentage, weight by volume percentage. So based on that, what type of questions they are asking in the examination. So first question is, if sea water is assumed to contain 40 grams of salt per 100 grams of seawater, then the salt percentage, then the percentage by mass of salt present in it. So salt percentage you have to find out. So now in case first, if you take 40 grams of salt is present in the 200 grams of seawater. So seawater nothing but it is a solution weight. They are mentioned the solution weight. Sir, weight of solute is mentioned, that is 40 grams. Weight of solution is mentioned, that is 40 grams. Sir, how it is? Sir, weight of solute, that is salt, it is equals to 40 grams. Then weight of solution they are mentioned, it is 200 grams. This is 40 grams, that is 200 grams. Then what they are asking, percentage by mass of salt present in it. Percentage we have to find out. Sir, weight by weight percentage of salt, it is equals to weight of solute divided by weight of solution into 100. Sir, weight of solute what is there? 40 grams. Then weight of solution what is there? 200. Sir, into 100. Then two zeros cancel here. Then 2 ones are 220 times. Then 20 percentage. So C is the correct answer for this. Understand all of you? Right. So next question, if you see. Next question. If 2 moles of CaCO3 is dissolved in 900 grams of water. Sir, here you have to observe one of the things. The solvent is only given. The previous question, salt, water they are mentioned. That is solution. Here only water is mentioned. That is 900 grams of water is there. Then percentage by mass of solution is formed. Percentage mass you have to find out. Sir, here first 2 moles of CaCO3 contains how many grams of CaCO3, that you have to find out. So that's what one of the formula is given. Sir, weight if you want to find out, weight of component, it is equals to number of moles into gram molecular weight. Okay. So number of moles, how many moles are there? 2 moles are there. So gram molecular weight of CaCO3 how much? Ca, it is 40. Then carbon, so 12. Then O3, that is 48. So total you can get it is 100. Clear? So number of moles 2 into 100, how much you can get? 200 grams. It is weight of solute. It is the weight of solute. Then weight of solution if you want to find out. Sir, weight of solution, it is equals to solute weight, weight of solute plus weight of solvent you have to take. Sir, weight of solute what is there? 200 grams. Weight of solvent what is there? 900 grams. Then total how much you can get? 1100 grams you can get. This is what weight of solution. Sir, weight percentage of solution in case if you want to find out. Sir, weight by weight percentage equals to then weight of solute divided by weight of solution into 100. Then 2 zeros, then 2 zeros cancel. Then 2 divided by 11, that is we can get it is 18.18%. Right. Next. So next, 60 ml of liquid A is mixed with another liquid B and solution was made up to 300 ml. Solution is made up to 300 ml. Find the volume percentage of liquid B in the solution. So here first, so liquid A is given. That is how much? Volume of A component is equals to 60 ml. Then volume of solution, they are mentioned, it is made up to 300 ml, made up to 300 ml. So this is solution. So but they are asking liquid B percentage. Are you getting my point? So sir, in case if you want to find out the liquid B percentage, sir, volume of B divided by volume of solution into 100 you have to do. But volume of B we don't know here. Sir, at that time first you have to find out the volume of A only. Sir, volume percentage of, volume by volume percentage of A component, it is equals to, or A liquid is equals to, sir, volume of A divided by volume of solution into 100. Volume of A, how much is there? 60. Then volume of what? Solution, how much is there? 300 ml into 100. 3 zeros, 2 zeros, 2 zeros cancel. Then 3 1 ja, 3, 20 times. Then how much? 20% will be there. Which is, sir, A components, this is. But they are asking B component, liquid B solution, how much percentage? So here 20% is there, the remaining percentage. So liquid B volume percentage equals to 100 minus 20, then you can get 80%. So 80% is the answer for this. Understand all of you? Right. So next question. Look at. What amount of solute is dissolved in 0.5 liters of solution to make it 20% weight by volume? Understand all of you? Right, look at. Sir, first 20% of weight by volume, nothing but. Sir, what does it mean? 20 grams of 20% of weight by volume means 20 grams of solute in 100 ml of solution. This is the meaning. Clear all of you? Right. So 20 grams is present in the 100 ml of solution. Then here solution volume is given. Sir, solution volume in the liters they are given 0.5 liters. Sir, in case in the milliliters, how much you can take the volume solution? Solution how much? Sir, 500 ml it is, 500 ml. Now 20 grams of solute, 100 ml. Then 500 ml in case, 500 ml of solution if you take. How many grams of solute have to take? So that is X. So X cross multiplication you have to do. So 20 into then 500 divided by 100. Then 2 zeros cancel, 20 into 5. Sir, 100. Sir, 100 ml, 100 grams, sorry, 100 grams. So 100 grams is the answer for this. How much? 100 grams is the answer for this. Clear all of you? Understand? Next topic is, sir, mole fraction. Sir, next concentration term. This is the fourth concentration term. Mole fraction have to discuss. Sir, what is the mole fraction? Sir, it is the ratio of number of moles of one component to total number of moles of all components in the solution is called as mole fraction. Sir, in case one of the solution contain two components. Sir, one is A component, then one more B component, like this will be there. Two components are there. Okay, one is A component, one is B component. Just assume it A component is solvent. A component is solvent. Then the B component is solute. B component is solute. Sir, A component it contains n number of moles. Then B component it contains n number of moles. Clear all of you? Right. So now How can you define the mole fraction? Mole fraction nothing but it is the ratio of number of moles of one component to total number of moles of all components in the solution. All components in the solution. Right, look at. So mole fraction nothing but it is the ratio of number of moles of one component to total number of moles of all components. Sir, in this particular solution, two components are there. One is A component, one is B component. So A component having number of moles A and B components having number of moles B. Then in case if you want to find out the mole fraction of A, it is equals to number of moles of A divided by number of moles of A plus number of moles of B. Like this you have to take. So mole fraction of B, in case if you want to find out, number of moles of B divided by number of moles of A plus number of moles of B. Clear all of you? So here, sir, remember one of the point, that is mole fractions of both components in the solution. Both components in the solution is equals to 1. It is equals to 1. So here how it is, mole fractions of both component I told, this is and this is. So both, in case if you add mole fraction of A, what I told, number of moles of A divided by number of moles of A plus number of moles of B. Then mole fraction of B, what I told, number of moles of B divided by number of moles of A plus number of moles of B. Clear? So now in case if you take, then number of mole fraction of A plus mole fraction of B, in case if you want to take mole fraction of A, what is there? Number of moles of A divided by number of moles of A plus number of moles of B is there, plus, so mole fraction of B, what is there? Number of moles of B divided by number of moles of A plus number of moles of B is there. Then now in case if you add both, number of moles of A plus number of moles of B divided by number of moles of A plus number of moles of B. So that's what, both will be cancelled, then you can get, it is 1. So unity, that is called unity. Sir, mole fractions of both components is equals to unity. Sir, in case ratio, if you take ratio of both components of mole fractions, both mole fractions if you take. So look at that. Sir, mole fraction of A divided by mole fraction of B, in case if you take mole fraction of A, what is there? Number of moles of A divided by number of moles of A plus number of moles of B. Then divided by number of moles of B divided by number of moles of A plus number of moles of B. Then you can take it as number of moles of A divided by number of moles of A plus number of moles of B. Then into number of moles of A plus number of moles of B divided by number of moles of B. Then both will be cancelled with each other. Then you can get it is number of moles of A divided by number of moles of B. This thing you have to remember. The ratio of mole fraction of A divided by mole fraction of B, that is equals to the ratio of number of moles of A divided by number of moles of B. This is one of the most important point. Clear all of you? This is in the mole fraction. So now in case, so one of the problem we'll see based on the mole fractions. Look at all of you. So calculate the mole fraction of each component in the solution formed by mixing of 30 grams of CH3COOH and 180 grams of H2O. 180 grams of H2O. Two components are given. So in the two components, we have to find out first number of moles of each component, because the ratio of any component, in case if you want to find out, for example CH3COOH, it is equals to the number of moles of CH3COOH divided by number of moles of CH3COOH plus number of moles of H2O, both you have to find. Understand? So that's what you have to find out, the number of moles of each component first. Number of moles of CH3COOH, number of moles of, if you want to find out, given weight divided by molecular weight, you have to find out. Sir, given weight, they are given already, right? Sir, given weight, how much is that? 30. Then molecular weight of acetic acid is 60. Then you can get it is 1/2. Sir, nothing but 0.5 is the number of moles of acetic acid. The number of moles of water, number of moles of H2O, in case if you want to find out. Sir, 180 grams they are given. So given weight 180, then divided by molecular weight 18, then how many times? 10 times. So 10 moles is there. Clear all of you? Right. So both moles we are calculated. Sir, both moles when it is substituted in this. For example, number of moles of CH3COOH, what is there? What is there? 0.5 is there. Then total number of moles, how much? Total number of moles 0.5 plus 10, then 10.5. 10.5. So now 0.5. So number of moles correct enara. Look at there. So 1/60, weight divided by molecular weight, 1/2, right? So 0.5. Sir, when it is, sir, 5 divided by, then 105 you can take, right? One divided by 21 times, right? Exactly correct, 1/21. Then mole fraction of H2O, in case if you want to find out. Sir, how can you find out easily? Sir, 1 minus mole fraction of CH3COOH. Sir, 1 minus mole fraction 1/21, that is equals to 20 divided by 21 you can get. Understand all of you? So mole fractions of both components you have to find out like this. Clear? Next one. Look at, if a solution has molar ratio of CH3COOH and H2O is 1:4. So molar ratio, that nothing but number of moles only. So number of moles of CH3COOH, it is equals to 1. The number of moles of H2O, it is equals to 4. So now total number of moles, ma'am, 5. Total number of moles is 5. So mole fraction of CH3COOH, it is equals to number of moles of CH3COOH divided by total number of moles. Sir, this is 1 divided by total number of moles, 5. 1/5. Then mole fraction of water, in case if you want to find out, it is equals to number of moles of H2O divided by number of moles of total. Number of moles of H2O, how much is there? 4 is there. So 4 divided by 5. So like that you can find out the number of mole fractions of each component in the solution. Next one, so we have to discuss about the concentration term, the most important concentration term, that is molarity. Sir, what is the molarity? Molarity you have to represent with a capital M, right? Sir, molarity nothing but the number of moles of solute, the number of moles of solute present in 1 liter or 1000 ml of solution. 1000 ml of solution is called molarity. So number of moles equals to, molarity equals to number of moles divided by volume in liters you can take. So based on this formula, you can write the units also. Sir, units are that is mole per liter. These are the molarity units. Clear? Right. So, sir, in case number of moles, if it is substitute in this number of moles, what is there? Given weight divided by gram molecular weight. So if it is substitute in the place of that, molarity equals to given weight divided by molecular weight, gram molecular weight, into 1 divided by volume in liters you have to take. Sir, one more formula, given weight divided by gram molecular weight, in case volume is present in the milliliters, 1000 divided by volume in the milliliters have to take. Understand? So this is the molarity formula. So in the molarity formula, sir, some more questions they are asking, specific gravity and density in case they are given in the question. So at that time, how to find out the molarity? Sir, molarity it is equals to weight percentage into then 10 into density divided by gram molecular weight. So this is the formula you have to find out for the molarity. Okay, right? So next, based on the molarity, some of the problems have to discuss. So problems based on the molarity. Look at. Yes, 500 ml of 2 molarity of aqueous solution has dash moles and dash grams. How many moles and how many grams? Sir, number of moles in case if you want to find out. Sir, from the molarity formula itself, actually molarity is equals to number of moles into number of moles divided by volume in liters I told, right? So then number of moles in case if you want to find out, molarity into sir volume in liters. Clear all of you? Then here volume is there in the milliliters. If you want to find out in the liters, so 500 ml that is equals to 0.5 liters, right? 0.5 liters. So molarity what is given 2, then into 0.5 liters, then how much you can get? 1 number of moles when moles are asking. Sir, here in the grams in case if you want to find out, so weight, nothing but weight of compound is equals to, what is the formula I told? Weight of compound equals to number of moles into gram molecular weight. Number of moles 1 is there, gram molecular weight of NaOH 40, so that 40 grams is the answer. Clear? Understand? So next question, look at. Next question, if you see, if solution has 6.022 into 10 to the power of 22 molecules of urea in 500 ml of volume, calculate the molarity of solution. So here they are not given any weight, they are not given any number of moles. Sir, but you have to calculate the molarity if they will give number of molecules. So when number of molecules are given, you can calculate the number of moles I told. You can calculate the number of moles. What is the formula? Given molecules divided by 6.022 into 10 to the power of 23. Then, so you can get it is 6.022 into 10 to the power of 22 divided by 6.023 into 10 to the power of 23. Then 6.023 cancel. Then 10 to the power of 22. Then minus 23, then you can get 10 to the power of minus 1, right? 10 to the power of minus 1 nothing but 0.1 moles. 0.1 moles you can get. So now what we have to calculate? Molarity have to calculate. So molarity it is equals to, so number of moles into 1 divided by volume in liters, 1000 divided by volume in milliliters. So number of moles 0.1 into 1000 divided by, then what is there? 500, then 500 ones 2 times, then 0.2 molarity is answer What are the units per molarity? Mole per liter or mole liter inverse. Clear? Right. Next one based on the molarity itself. Solution of 2 molarity of 500 ml is diluted to 10 times. What will be its a new molarity? They're asking question. Such type of question. When it is diluted, they're asking question. So how to find out this? Sir, here actually one of the molarity and volume is given. For example, this solution having molarity M1, then volume V1. When it is diluted, nothing but volume will be increases. So just assume it, when it is diluted, volume increases. Now this is M2 and V2. One of the thing you have to observe, volume only increases, nothing but solvent only increases. Solute as usual will be there. Solute, how many number of particles are there? The same number of particles are there. How many number of moles are there? At starting, same number of moles are there. So number of moles of this compound, it is equals to number of moles of this compound, both are equal. Nothing but, sir, M1 V1, it is equals to M2 V2. Understand all of you? This formula you have to use for this. Sir, here first molarity is given. M1 equals to 2 molarity. Then volume V1 equals to 500 ml. Then volume is increased 5 times that of first one. 10 times that of first one. 10 times nothing but V2. It is equals to 500 ml into 10. How many times? 10 times. Then how many milliliters? 5000 milliliters. Then what you have to find out? M2 you have to find out. Molarity. The new molarity. So next, sir, M2, it is equals to what? Sir, M1 V1 divided by V2. Sir, M1, what is there? M1 2 into 500 ml divided by 5000. Then 2 zeros cancel. Then 5 ones, 5 tens, then 2 ones, 2 5. So 1 by 5 how much? 0.2 molarity. That is answer. Understand? So next one more question look at. Sir, what is the molarity of solution of HCl which contains 49% by weight of solute and whose specific gravity is 1.41? Sir, at the time when specific gravity and weight by volume percentage is given, then direct formula is there. I told that, sir, molarity equals to weight by weight percentage into then 10 into then specific gravity. Even in the place of specific gravity, even density is given, also same formula you have to use. Specific gravity divided by gram molecular weight. So weight by weight percentage, how much is there? Weight by weight percentage, 49% is there. So need not to convert the normal weight. So percentage as usual you have to take. So 49%. So then into 10, then into specific gravity 1.41, then divided by gram molecular weight. Gram molecular weight of HCl, Cl 35.5, then H is equals to 1, 36.5. So 36.5 if you take, then you can get the answer 18.92 molarity for this. Understand all of you? Right. Then here one of the point you have to remember, the strength of the solution. So generally molarity of the solution we are seen. So volume of the solution we are seen, weight by volume percentage of the solution we are seen. Then strength of the solution they are asking. Strength of the solution. In case if you take in the chemical laboratories, HCl solution will be there. In the brown color bottles, HCl solution will be there. In that, if you observe the strength of HCl solution, they are given. That is 17 grams per liter, like that. 17 grams per liter. Sir, what is the strength of solution? Strength of the solution, nothing but strength of solution, nothing but the weight of solute, the weight of solute in grams, the weight of solute present in, the weight of solute present in, weight of solute present in 1000 ml of solution, 1000 ml of solution, or 1 liter of solution, 1 liter of solution is called strength of solution, is called what? Strength of solution. So here, so strength in case if you want to find out, strength equals to, sir, weight of solute divided by volume of solution in the liters. You have to take volume of solution in the liters. So in case 17 grams per liter, 17 grams per liter is the strength of HCl solution if they are mentioned, then at that time what does it mean? 17 grams of HCl, it is in the weight, 17 grams of HCl is present in then 1000 ml of solution, 1000 ml of solution or 1 liter of solution. Understand all of you? So in case if they will give strength of solution, you have to calculate in the molarity if they will ask. So first you have to note it the statement like this. Then after, sir, weight you have to convert it into number of moles. Then after, molarity formula you have to use. Number of moles divided by volume in the liters. Clear? Right?